Hello everyone, welcome back to the online class of class 10, chapter number 13, magnetic effects of electric current. So today we will be learning about the electromagnetic induction. Till now we have learned the process of generating magnetic field through a coil or through current moving through, means current moving through any conductor. Now when current moves through any conductor, it generates some magnetic field within the conductor. Today we will see the reverse process of this. That means generating electric field by using a magnet. Electromagnetic induction means generating electric field by using or moving a magnet near a coil, near a solenoid or near a coil. This discovery was made by Michael Faraday in the year 1831 when he discovered that a moving magnet can also produce an electric field related to any circuit or to any conductor in which it is used. So basically what Faraday did was he took a coil and connected the coil to a galvanometer. The coil was taken and connected to a galvanometer. Now galvanometer is a device which detects the presence of electric current in any circuit. That means if in any circuit current is flowing through it from any direction, then the galvanometer shows from which direction current is flowing. So basically a galvanometer has a round dial with a written small like G, and inside it there is a pointer. Basically the pointer is at center point, means normally points at 0, but when it is connected to any circuit, current flows to the circuit, and from wherever the current flows, means wherever the positive is, the galvanometer pointer moves to that point, it points to that direction. If positive is this side, then the pointer will move to here, and if the positive is the other side, then the pointer will move to the other side. So this is basically a galvanometer. So galvanometer detects or tells us about the presence of electric field in any circuit. Now what Michael Faraday did? So he took a coil, a solenoid, and connected it to a galvanometer. Then he took a magnet, piece of bar magnet, and moved the magnet forth and back. Means if he moved the magnet near the conductor and took it away, he was moving the magnet close and back, means back and forth, he was moving the conductor near the coil. So due to which what happened, when the magnet is going near the conductor or near the coil, the magnetic field in the coil used to increase, and when the magnet was taken apart, it was taken away, the magnetic field decreased. Due to this change in magnetic field in the conductor, the electrons present in the conductor start to move, and when the electron moves, we know that electricity is generated, or it is basically termed as electricity, or moving current, basically electricity. So this is how he showed that that moving a magnet back and forth near a coil can help us to generate electricity. So this was his breakthrough invention or discovery, and then basically it's an invention, and that was known as electromagnetic induction. So electromagnetic induction, we can say like generating electricity by moving a magnet near coil, by moving a magnet near a coil. So this is the electromagnetic induction. You can write it down. So this activity, this experiment was performed by Michael Faraday in 18 31. Now there are two ways in which electricity can be produced within a coil. First of all, moving a magnet near a coil, moving the magnet back and forth near a coil, and the second one is taking two coils. The second way is taking a piece of non-conducting device, for example a piece of wood, long piece of circular wood, and then in one side a coil is wounded. Coil is wounded there, and then in the other side, in the other part, there is a small coil, secondary coil, wounded there. This is the second method. So what happens here? Two coils are taken. One coil has more number of turns and the other one has a small number of turns. This is coil 1 and this is coil 2. Coil 1 is the primary coil, coil 2 is the secondary coil. Now coil number 1, that is the primary coil, has more number of turns than coil number 2, and the primary coil is connected to a battery, means a power source, and the coil number 2 is connected to a galvanometer. Now we have learned till now that when current passes through any solenoid or a coil, it produces magnetic field within the coil. So when the switch will be turned on, the coil number 1 will act like a magnet, and its magnetic field lines will move or go towards the coil number 2, or will move through coil number 2, and when it will be turned off, the magnetic field lines will stop. So if this coil 1 is turned on and off continuously, what will happen? Magnetic field will go to the coil number 2 and again reduce. So when the coil 1 is turned on, magnetic field will move towards the coil 2, and when it is turned off, magnetic fields will also stop. So with this continuous turning on and off of coil number 1 will induce or will act as a moving magnet, or will change the magnetic field lines in coil number 2. So when the coil 1 is turned on, magnetic fields will increase in number 2, and when coil 1 is turned off, magnetic field will reduce in coil 2. So with this change in magnetic field in coil 2 due to coil 1, it produces electricity in coil number 2. It will show, this galvanometer will show some deflection of current in coil number 2. So this is the second method. First method is this one, moving a magnet near a coil. Second method is using two coils, one primary coil, one secondary coil, and turning the primary coil is connected to a power cell which is turned on and off continuously, which changes the magnetic field in coil number 2, which in turn produces electric field in coil number 2. So these are the two ways in which magnetic field or electric field can be generated by using a magnetic field, or this is the two ways for electromagnetic induction. Now we'll see that in which directions will this current be generated. Like we learned previously in the force due to a current carrying conductor, that we learned there that Fleming's left hand rule. So the forefinger was the direction of magnetic field, the middle finger was the direction of electric field, and the thumb shows the direction of current. So with this method we can know that how this electric and magnetic field can generate a force which can make a conductor move. Now in this we have the magnet, we are giving the motion or the movement, and finally electricity is generated. So to know about the direction of electric field, here we use Fleming's right hand rule. Fleming's right hand rule. So in Fleming's right hand rule, we extend our fingers like this of the right hand, just like this left hand. We extend our fingers like this, where the forefinger shows the direction of magnetic field, the thumb shows the motion of conductor, and the middle finger pointing in any direction shows the direction of electricity produced, or the direction of induced current. Thumb magnetic field, forefinger magnetic field, thumb shows the direction of motion, means moving of the magnet or moving of this one, turn of the moving magnet we can say, and the middle finger shows the direction of electric field. So here forefinger shows our direction of magnetic field, thumb gives motion or movement of the conductor or the magnet, whatever we use, and third one is our which gives the direction of induced current. So this is the last part of our chapter which is required for the exam. So you can write it down. So this much only is required for our exam or your syllabus this year. So here we finish our course of physics. Thank you.